Okay, so again, this is still 1.7, but this is just absolute value inequalities. And I want to kind of show you why they work the way they work before we just get into remembering GoLA and going from there. So, if you'll give me 2 seconds. All right, so it says the absolute value of x is less than 9. So let's take a look at our number line. We got 0, we got 9. What else has the same absolute value as 9? Negative 1. Okay, so I'm going to show this here. Okay, so if we're talking about an absolute value of less than 9, that means a distance from 0 of less than 9. So if I'm looking at my number line, here's my 9. Where are my numbers that are going to have a smaller absolute value than this? To the right or to the left of it? To the left. So it's basically everything up to 0, right? But we also have to take into consideration the opposite number. So if I think about negative 9, it still has an absolute value of 9. Where are the numbers that have less than an absolute value of 9? To the left of 9 or to the right of 9? To the right, okay? And if we think about that, what kind of graph does that look like? And or? It looks like an and graph, right? Make sense? Okay. I'm going to come back and do it with the easier way to do it, but I just kind of want to show you how it works. And then if I look at the other one up there, x is greater than or equal to 2. That means I need an absolute value bigger than 2. So we're going to look at this. 0, 2, and negative 2. So where are my numbers that have an absolute value bigger than 2? To the right or to the left of 2? To the right. Now it's greater than or equal to, so we're going to close it. And we're going to shade to the right. But we got to think about the numbers on the opposite side. Where are the numbers that have an absolute value greater than 2? In between 0 and 2 or to the left? Think about the numbers. Negative 1, is that an absolute value greater than 2? What about negative 3? Is that an absolute value greater than 2? And what kind of graph does that look like? That looks like an OR graph. Okay. So what we're going to do is the steps are very similar to what we did yesterday. The first step is to isolate your radical by itself on the left of your inequality. Not radical. Did I say radical? I meant absolute value. Okay, I isolate that absolute value on the left of the inequality. So if I take a look at the first one, now we already did the work for it just to show you how it works, but we'll talk about how you do it without having to do that every time. So is my absolute value all by itself? It is, okay. Then the second step is we're going to have to set up 2 inequalities. Using GoLA, okay, or GOLA, or whatever you want to say. GoLA is what I usually call it. Now, obviously, that stands for something, right? What do you think? If it is, we're talking about inequalities, what would G be? Think about inequalities. Greater than. If the inequality is a greater than, if the absolute value is greater than, what joining word should we use? Or. And then if the absolute value is less than, we should use the joining word and. That's what GoLA stands for. Once the absolute value is isolated by itself on the left side of the inequality, we're going to decide, do I use and or do I use or? In this case, it is the absolute value of x is less than 9, so what would we use? And this is what we're going to do. Maybe. We are going to do x, we're dropping the absolute value bars, is less than 9, and there's a little trick to how we set up this second one, okay? We were less than 9, right? But how would we represent this? Or if we're talking about negative 9, what are these numbers? Greater than or less than? Greater. They're greater than. So when you set up that second inequality, x stays the same, less than is going to turn to greater than, and positive 9 is going to turn to -9. I'm getting the hiccups, I'm sorry. Okay, so the first inequality stays exactly the same. Drop the absolute value bars, leave it as it is. Decide which words you're going to use, and or based off of that inequality. Greater than is or, less than is and. And then when you write that second one, you are going to flip the inequality and change the sign of the number. Once you do that, we go to our graph, because remember with compound inequalities, we have to check our graph, although we already have it up on the board. And then I've got to talk about where these situations are true. The first one says x is less than 9, which is an open circle, and goes to the left. Remember, we're drawing, like we did the inequalities the other day, we're drawing them above before we shade. And then the other one says x is greater than -9, that is open, and that is going to the right. And since we chose to use the word and, we only want to shade when they are both true. Where are they both true? In the middle. So we're going to shade there. And we're also going to write our answers in interval notation from this. What would that look like? Parenthesis or bracket first? Parenthesis, what's the first number? -9, comma, what's the next number? 9, and then parenthesis or bracket. Parenthesis. Okay. We will at some point run into some special cases like we did with those compound inequalities on Friday. But once we get it set up, isolate the absolute value, set up your two inequalities using OLN, I didn't finish my steps. Solve each inequality. And then graph. Well, I guess you need to state your answer. We're going to set our answers in interval notation. The biggest mistake that people make with these is, first of all, they use the wrong joining word. So just remember, go LA. And then the other one is forgetting to change the second inequality and the sign of that second number, or that number when you do that. Okay. All right, so we're going to go ahead and do the second one. Even though we have the graph on the board, we know what it should be. We're going to talk about how to do it without even looking at the graph. Is my absolute value by itself? Yes. Is it on the left side of the inequality? Yes. Okay. Then we're going to set up our two inequalities using go LA. Is that a greater than or a less than? Greater than, so we should use or. Remember, the first one stays exactly the same. The second one, the x stays the same. That greater than is going to switch to left then. Just think about you're flipping over 0 on the number line. So we have to flip everything around from there. We're going to go less than or equal to, and instead of +2, we're going to change it to -2. And then just like those compound inequalities, we have to go to our graph. The first one says I am greater than or equal to 2, so I'm going to close my circle. Greater than goes, it would help if I put my numbers in the right place, wouldn't it? Let me try that again. -2 goes on the left. Sorry about that, y'all. All right, so I'm greater than or equal to 2, so that is closed and going to the right. I am less than or equal to -2, which is closed and going to the left. The word is or, so I only have to have one true, but I could also have them both true. Starting on the right, do I have at least one of them true there? Yes. Do I have at least one true on the middle? Nope. What about one on the left? Yes. Okay, that is the normal OR graph. We can go ahead and write our interval notations based off of that graph. Remember when we have the two separate shaded areas, we have to do the union. So let's start on the left side. How far left do I go? Negative infinity all the way to -2, and that's a bracket because it's equal to. And then in union with, what's the other one going to look like? There you go. Anybody have any questions? Let's take a look at these two. If you'll write number 3 down, we're going to work through this one together, and then I'll let you try 4, and then we'll get into some special cases. The absolute value of x plus 2 is less than or equal to 4. First question, is my absolute value all by itself on the left side of the inequality? Yes, okay. Less than, greater than or less than? Less than, so that means what word? Hey. Oh, Lexi, I'm sorry, I was not looking at that. I looked at the first name, sorry.
Thank you.
So what did we say, and or? Less than is and, right? Go, LA, greater than or less than and. And we're going to set up our first one exactly the same. It is just x plus 2, less than or equal to 4. Nothing changes on that one besides losing the absolute value bars. What's the second one going to look like? Perfect. X plus 2 is greater than or equal to -4. Solve each one of those now. Once you get it solved for x, then you want to go to your graphs. Represent where each one is true, decide where they are both true at the same time, shade there, and write your interval notation from that. All right, it says I am less than or equal to 2, so that is closed and going to the left. Then it says I am greater than or equal to -6, that is closed and going to the right. The word is and, so where should I shade? In the middle. And what would my interval notation look like? There you go. Go ahead and try 4. my absolute value all by itself on the left of the inequality? Yes, okay. Am I going to use and or or? What symbol is that, greater than or less than? It's less than, right? If you're not sure, straighten them up, whichever one looks like an L is less than. Right? Does that make sense? So that is less than, so we're going to use and. Remember, go LA, greater than or less than and. The first one stays exactly the same. X minus 1 is less than 3, just without the absolute value bars. The second one is X minus 1 is going to be greater than negative 3. So I get X is less than 4 and X is greater than negative 2. Negative 2 is my smaller number, so it is going to go on the left. I am less than 4, that is open, and going to the left. I am greater than 2, which is open and going to the right. The word is and. Where are both the green and the yellow at? Where do they overlap? In the middle. And then what would my interval notation be? Okay, parentheses for both, not equal to, negative 2 to 4. How do we think about those? Good. Okay. I'm going to do one more, I think, if I remember looking at my notes, and then I'm going to get to some special cases, because, all right, skip 5, do 6. Okay, skip 5, do 6, and then we'll get to a couple of special cases. I want to make sure we remember. A fraction of one of these numbers, just simply leave it as a fraction, change it to the decimal. What do you think the one thing I'm trying to make sure you remember is? Divide by a negative, exactly. When we're dividing to get rid of that negative 3 that's in front of x, we're going to have to flip our inequalities again, even after you've already flipped one of them. Is my absolute value all by itself? Yes, it's on the left side. Greater than or less than? Greater than, so it's going to be 4. Do not change the order of the 4 minus 3x. If you do that, you're changing the whole value of the number. The second one's going to be 4 minus 3x is less than or equal to negative 1. Ooh, that was almost bad. I'm going to subtract 4 first. That gives me negative 3x is greater than or equal to negative 3. But I have to divide by negative 3 to solve, which means I'm going to take and flip that inequality. So it becomes x is less than or equal to 1. Don't forget to bring your word down, because then when you go to the graph, if you don't have that word right there, you might lose it. So just make sure when you're solving, you bring that word to the bottom. I'm going to subtract my 4 over here again. I am also dividing by a negative 3 here, which means that I do this. I have to flip the inequality, so that one becomes greater than. And if I have a negative 5 divided by a negative 3, it does not go in evenly. So you can either leave it as a fraction, or if it helps you to decide where the numbers go, you can change it to a decimal. And that would be what, a positive 1.6 repeating? Again, you can also just leave it as 5/3. So when I go to my number line, which one is the smaller one? 1. I am less than or equal to 1. That means I'm closed and going to the left. I am greater than or equal to 1.6, which means I'm closed and going to the right. The word is or, so I only have to shade where one of them is true. Where do I shade? Do I shade on the left? Do I shade in the middle? Do I shade on the right? Okay. And then as far as my interval notation goes, where do I start? Negative infinity, comma, 1 in a bracket, in union with the bracket again, 1.6 repeating to positive infinity. And everybody knows that little bar that I put over the 6, that just means it's 1.6 repeating. Okay. I have any questions so far? All right. Let's take a minute and write down number 7. We're going to work through this one together. So if you remember correctly, yesterday when we were doing the equations, we said that if there's a number in front of the absolute value bar, you do not want to distribute it, right? Yeah. You want to divide by it instead. It really doesn't have too much of an effect on the equations, but it can on the inequality. So that's why we have to be very careful with this. So the first step is to isolate the absolute value. Is my absolute value by itself? No. What would I have to do first? Subtract 2 first. So that's 5 times the absolute value of x minus 1 is less than or equal to 5. What next? Divide by 5, yep. Those 5s are going to cancel. Finish it from here. Now your absolute value is all by itself. So you want to decide and or based on is it greater than or less than. Set up your two inequalities, solve and go to your graph. And or. And so when I solve, I get x is less than or equal to 2, and, whoops, is 0 okay to have as part of my answer? Yes, 0 is a real number on the number line, so it is okay to have it as an answer. We're going to set up our graph now. 0 is smaller than 2, so it goes on the left. I am less than or equal to 2, so that is closed and going to the left. I am greater than or equal to 0, which is also closed and going to the right. So we shade in the middle. That's where they both are. And what would my interval notation be? Perfect. Bracket 0, comma 2, bracket. Bless you. So far, so good. I want you to start working on number 8. Okay, and what I mean by that is we need to get that absolute value all by itself first. So I want you to start working on isolating that absolute value. So what would I have to do? So imagine it like this. Imagine an equation, 7 minus 3, but instead of that absolute value stuff, imagine we just put x there. What would you have to do then? You'd have to subtract that 7 over, okay? So let's do that first. Now what would I have to do? Divide by what? -3, but this is an inequality. So when I divide by that -3, what am I going to have to do? Flip it. This is a case where if we were to distribute instead of divide, it's going to change your answer. Because if you just distribute, you're not going to flip it. You're going to be using greater than, and that would give you the wrong answer. So it is the absolute value of x plus 2. But it is no longer greater than or equal. It is now less than or equal to 7. Okay, so this is why it's important not to distribute a number in front of an absolute value bar, excuse me, especially with inequalities. Go ahead and finish it. Remember, we don't decide and or from the original inequality. We decide it once we isolate the absolute value. So am I going to use and or here? And I don't know why I did that. So I get x is less than or equal to 5, and x is greater than or equal to negative 9. I am less than or equal to 5, which is closed, and going to the left. I am greater than or equal to negative 9, which is closed, and going to the right. And because we are using and instead of or, where do we shade? In the middle. Oops. Bracket, negative 9, comma 5, bracket. Everybody okay with that? What do you mean? Yeah, you want your smaller number on the left. All right, try that one. Remember to isolate the absolute value first. Remember, when you write your interval notations, your smaller number should always be on the right side, just like on your graph. First of all, what do I have to do to get it by itself? Subtract the 10. Okay. So I get the absolute value of x minus 5 is less than what, negative 8? Okay. So less than means what? And so when I add my 5 over, that gives me x is less than negative 3, and x is greater than 13. If I am less than -3, that is open and going to the left. Greater than 13 is open and going to the right. Where are they both true? They are not. So we would say no solution. Pay attention to this right here. See what I just highlighted? The absolute value of x minus 5 is less than what kind of number? Which means it would always be a negative, right? Can absolute value ever be negative? So some people will get in the habit of seeing that, and once you get that absolute value by yourself and say, oh, well, you can't be less than a negative if you're an absolute value, so therefore it's no solution. Okay. Now, I didn't put in one of the other cases. I just want to real quick show you. If I have the absolute value of x is greater than -1, what do you think that would be? Greater than? Let's take a look. What's greater than? It's or, right? Greater than -1 is open and going to the right. Less than 1 is open and going to the left. But this time the word is or. Can I shade to the left? Do I have at least one of them there? Can I shade in the middle? I have 2 of them there, so that's at least 1. And then can I shade to the right? Yeah. I can close in -1 and +1 because they satisfy either one. In that case, what would I say? -infinity to +infinity. Pay attention right here. Is my absolute value always going to be greater than a negative number? Yeah, because it can't ever be negative, so it's always going to be bigger than a negative, right? So those are the 2 specific special cases that you may see a lot. So just pay attention to that. Pay attention to your graph.